Okay, so this is section 3.4, real zeros of polynomials. So this is the rational zeros theorem. We're going to use this to find zeros of polynomials. So given a polynomial of the basic form, coefficient a sub n times x to the n plus another coefficient a sub n minus 1 times x to the n minus 1 all the way down to a sub 1 times x plus your constant term with integer coefficients. So all of your a terms are integers. Okay, then every rational zero of the polynomial is of the form p divided by q, where p is a factor of the constant term and q is a factor of the leading coefficient. Okay, so every zero of this polynomial can be found by looking at the factors of the constant term and the factors of the leading coefficient. All right, so let's use this in an example. Okay, so we have the polynomial x to the third minus 3x plus 2. So we want to look at the factors of the constant term, plus or minus 2 or plus or minus 1. Okay, and then we want to look at our leading coefficient. Our leading coefficient is 1. So that makes it easy. There's only two possibilities, positive 1 or negative 1. Okay, so these are all the possible zeros. So our possible zeros are positive 2, negative 2, 1, or negative 1. So we want to use these to decide which ones are the zeros. So there's two ways to do it. We can use synthetic division or we can substitute. So why don't we try to substitute these and see if we can find a zero. So let's start with 1 because it's easy. Okay, so 1 to the third is 1, minus 3 plus 2 is 0. So 1 is a 0. We have a possibility of 3 zeros, so let's try the others. Let's try negative 1. So negative 1 to the third minus 3 times negative 1 plus 2 is negative 1 plus 3 plus 2, which is 4. So this is not a 0. Let's try 2 and negative 2 now. So p of 2 so 8 minus 6 plus 2 is 4. So also not a 0. Let's try negative 2. So negative 2 so negative 2 to the third is negative 8 plus 6 plus 2 is 0. So our two zeros are 1 and 0. All right, let's look at another example. So this was just finding the zeros. The next example is we're going to find the zeros and factor at the same time. Okay, so we want to think about all the possible zeros, and then we actually want to use synthetic division this time, since we're going to be factoring this. Okay, so all of the factors of 6. So positive or negative 6, positive or negative 3, positive or negative 2, positive or negative 1. Okay, and then we want to divide that by all the possible factors of 2. So we can divide by plus or minus 2. Or we could divide these same factors of the constant term by 1. All right, so all our possible zeros are of the form p divided by q. All right, so if I simplify these, let's see what our possibilities are. Okay, so 6 divided by 2 means we could have positive or negative 3. We could have positive or negative 3 over 2, positive or negative 1, positive or negative 1/2. We could have positive or negative 6. 3 is already taken care of. Positive or negative 2, and 1's already taken care of. So let's go ahead and try one. So we're going to use synthetic division. All right, so let's start with 1. So 2, 3, and we can see that this is not going to give me a remainder of 0. So 1 is out. Let's try negative 1. Okay, so 1 didn't work. Let's try negative 1. All right, so bring down the 2. 2 times negative 1 is negative 2. Add those. Negative 1 times 1. All right, and this one's not going to work either. So next I'm going to try 2. Okay, so 2, bring down the 2. 2 times 2 is 4. Oh, look. This one's a 0. Okay, because we have a remainder of 0. So x minus 2 is a factor. Okay, so now that we found one factor, we know that our polynomial is equal to x minus 2, because 2 is a 0. Okay, and my quotient would be 2x squared plus 5x minus 3. We want to factor completely, so let's look at this and see if we can factor further. So 2x and x, and if I put 3, will that work? No. Let's put the 3 here, plus minus 1. So there it is, completely factored, and my zeros are going to be 2 from this one, 1/2, and negative 3. And if you notice, all of the zeros that we found are from this list right here that we made using the rational zero theorem. Okay, so we tried a 0 until we tried all the possibilities till we found a 0, and then we continued factoring. Okay, so I want you to go ahead and try p of x equals 4x to the third minus 7x plus 3. So first list all the possibilities using the factor theorem, find a 0, and then factor completely